Hello everyone, my name is Hardik. I work at Headout as an apps engineer, and I'm also a React Native contributor. I've contributed to a lot of different modules on the Android side in the React Native source code. So if you are using version 0.77 or above, you are probably running my code in your Android applications. And in this talk, I'm going to talk about native modules and how you can use native modules to add more platform-specific features in your existing React Native apps. Yeah, so to summarize, we all love React Native. React Native is great. And with React Native, we have a single code base for Android and iOS. We can do faster development because of hot reload. Gone are the days where we would basically recompile after every UI change and everything. And since React Native is based on the Web React framework, there is a large community and ecosystem of libraries. They are both interoperable on React Native and React. So that's great. And React Native aims for cross-platform parity. So at least we have some confidence that if we are going to build on Android, it would probably work the same way on iOS as well. But React Native, even though it's very great, it's still not perfect because React Native, for its aim, it's built for parity. It doesn't really focus much on platform-specific features, which typically exist outside the user interface. So let's say you are in a state where you want to build a feature that exists only on a single platform. Let's say you want to build support for something that is only there on Android, or you want to build something that is only there on iOS. And even if that's not the case, let's say you just want to build support for a library that might be providing you with the iOS pods or the Android dependency, but they don't really have an React Native package to you. What could be the solution in that situation? Because still you want to build support for that thing in your app, right? But it's not supported by React Native directly. So what would be the solution for it? That would obviously be native modules. Native modules as a feature were actually introduced to solve this particular problem. It was introduced to bridge the gap between the JavaScript side and the actual native platform on which the app is running. And native module as a feature has been part of React Native since its launch in 2015. So it's been a core part ever since React Native was created. And this is especially useful because not everything can be built in JS. So you do need that layer of abstraction where you build your thing in JS, along with you have the specific platform code as well. And native modules serve as the foundation for a lot of core libraries. So for example, if you are making use of camera in your React Native app, you are probably using most likely the actual native module that is running the actual native code based on the platform it's running on. And native modules, they do seem a bit complex when you might start looking into it first, but the overall idea is pretty simple. So if your user is using the React Native application, they would most likely be, for most of the part, interfacing with whatever logic or whatever UI has been bundled in the JS bundle. But at any point of time, the user wants to run something that is platform specific or it exists in the native module. So the native module would be loaded and it would be executed. And we get the response back to the React Native side. And once we have the response, we can technically do anything with it. So overall, the idea of native module is pretty simple. And to use native module in your application, there are three main steps which we follow. First step is that we create a type specification for our methods and variable that we want to have. So this file would basically tell as to what common functions would exist between the React Native side and on the native side. And once we have this specific spec file, we would set up a code generation library to actually generate the base classes in Kotlin, Swift, C++, or in Java. And once these two steps are done and we have the base libraries, we would simply just override those classes and we would implement with whatever platform specific code we want to run. Yeah, so these are the three actual options that we have as of now to implement native module as a feature in our React Native application. First is the OG native module, which is now known as Turbo Native Module. And native module was as we discussed, it's been originally since a part of React Native since 2015. It was called native module originally, so which is why I'm referring it to as native module. But since the introduction of new architecture, the entire framework got updated and it's now known as Turbo Native Module. And with Turbo Native Module, we get a code generation system that essentially generates all our files for us. And that is important because before Turbo Native Module, we had to sort of manually manage the platform specific files and the classes and the function definitions and everything on the native side and on the React Native side. And Turbo Modules makes use of the JSI for communication, which is much more faster than the older architecture where it would have to serialize back and forth in JSON just for communication. So this is about Turbo Native Module. The second option that we have is, which is also pretty popular, is Nitro modules. Now, Nitro module is very similar to what Turbo Native modules are, but it's a third-party framework that is developed by Margello. And Margello is like a design studio. They build apps and everything. It has a very similar framework and everything. They use a similar kind of specification to Turbo module, and they have their own library for code generation that they call as Nitrogen, and it's built on the JSI foundation as well. The feature that Nitro module claims to have benefit over Turbo module is performance. They claim that they can run the same code with like 5 to 10% more performance, or like even faster in many cases. And the last option for Expo specifically that we have is known as Expo module. And if you're using a completely Expo managed workflow, then you can implement platforms code using the Expo module system. In Expo, you basically have a module parent class which you will implement, and you will like basically fill out whatever platform specific code you want to have. Now, if you want to make use of Nitro modules or Turbo modules, you will need to come out of the Expo managed architecture. So you'll have to eject your project. And once that is done, when you actually get access to the Android and iOS build folders and everything, you can make use of Nitro module or Turbo modules and whatever option that would be suitable for you. Cool. So with all of this information, I have a quick demo which I want to show. Yeah. So this is a very small demo which I made for Turbo modules. So here in the app, we have 3 different kinds of input. I can write in something like, do you like React Native? I can also enter like a positive title, that would be yes and no. And once I'll press on this show alert dialog, I'll essentially get this dialog pop-up of iOS. And if I'll click whatever button I'll click on, I'll get the result back in my view. And similarly on Android, I can do the same. So I can write something like React Native, and I can write yes, no. Here, if same thing, if I'll press a button, I'll get the pop-up, and I can press a no to get the response as the user tapped on negative. And now, with this demo, whatever prompt that we are showing, this is actually coming from the Turbo Native module. This is not being generated by like any React Native library or anything. We have like I've written a Turbo Native module that is going to show this prompt and handle the response as well. So to quickly go over the code. So this is the basic code that we have. So as we discussed, so the first step is to basically have a spec file. Now for the spec file, I have the spec file with the function, same like a simple function called show dialog. This show dialog function essentially accepts the message that we want, whatever message that we want to show, the positive button label and the negative button label, and it's returning a promise. Now this is returning a promise since this alert dialog is not a blocking component. So the user can respond to it at any point of time. So we want to access the result at like accordingly, which is why we are returning a promise here. And the return type is string. Now this particular spec file is being saved as with the name native dialog. Now this was the step 1 of how we set up a Turbo Native module. In the package.json, we need to set up a CodeGen config as well, so that the React system would know that we have a native module that we have set up. Now here we would basically provide the name and the JS directory and everything. And for the Android specifically, it also requires like the name of the package you want to generate like the base classes into. So with these 2 things done, we pretty much have the native module set up, and after that we just have to implement the actual platform code. I'll also quickly show how we are making use of this native module before I show the native code. So this is the app.tsx file that we have. Here I have a pressable which is calling the show alert function when I'm pressing on it. And here I've imported the native dialog native module. This is from the file that I've created here, that is the native dialog.ts file. And inside here, I'm basically like very simply like any other function, I'm calling the show dialog function, and I'm passing in whatever state props that we have for the message and the positive and the negative label. And since it's a promise, we get the result accordingly. So like if it's correct resolved, it's correctly resolved, I'm getting the result properly. And there is not any error there, I will just setting the dialog result accordingly. And if the promise is like rejected, then I'm catching the error here. I'm also like setting the result accordingly. So here on the platform side, I'll show you what happens. So once you, so also to actually generate the platform specific files, you need to run 2 specific commands. So for iOS, you will run the normal pod install command, and this would basically create all the Objective-C++ base files in your Xcode project. And for Android, you need to run this particular Gradle task, that is generate code gen artifacts from schema. This would basically create like base Java files, and you get to populate and implement the methods accordingly. So for Android, this is what happens. So once I run the specific like that generate Gradle task, this particular package is created. This is from the, this is taking the name that we provided in the package.json, and this native dialog spec.java file is created. You'll also get the error that this is a build file. So this is generated dynamically by the build system. And here is the exact function that we defined in the spec file. So it's getting the message, the positive label and the negative label. And since the return type was a promise, there is an additional parameter here called promise, which we basically would be making use for to resolving or rejecting the promise accordingly. And to actually implement this class, I've simply made a new class called native dialog module, and this is basically overriding the existing native dialog spec. And here I get to actually write the code which I want to execute. Now, if I'll comment this out, Android Studio will actually ask me to implement this method. So like it will basically give me the error about its implementation. Like it's asking me to implement it. So this is basically the implementation of the actual platform code which I want to run. This is a very simple code that basically creates an alert dialog and uses the message and the positive label that we are getting. So I'm setting the message here. The positive button label is set accordingly and the negative button label is set accordingly. And based on whatever interaction the user does, if they tap on the positive button, I'm resolving it with the message that the user tapped on positive. And if the user taps on the negative button, I am rejecting it with a simple error code and with the message that the user tapped on negative. Now, to actually make use of this module class, we just have to set up a package class as well. This is all like boilerplate stuff which is mentioned in the documentation. And basically, after setting up the package class, we just add it in our main application here. So this was for Android. On iOS, the steps are fairly similar. So on iOS, the steps are fairly similar. We need to basically create a new group here in Xcode with whatever name that we want to have. So I've given the name native dialog. And we need to set up some header files as well. And these header files would actually import the actual spec file that is generated for the Xcode projects. And the thing with the turbo native modules on iOS is that it generates the code in Objective-C. So if you actually want to make use of Swift, you will need to set up a bridging header as well. This is like all part of the documentation. So there's like nothing specific here. And but for the actual native dialog implementation, this is the Swift code that I have. It's very similar to what I had on Android. I just have I'm getting the message, the positive label and the negative label. And for the promise, I'm getting a resolve function and a reject function. So I'm showing the alert dialog here. And whenever the user would tap on the positive button, I'll just resolve it with the message that the user tapped on positive. And whenever they'll tap on the negative button, I'll just reject the promise and say that the user tapped on negative. So just to showcase it very again, this is the promise and the turbo native module here. So I'll write something like, let's say I just have a question mark string. It is going to basically make use of that string to show the dialog, and I'll get the response accordingly. So this was a very small demo. I have another demo which might help in understanding more about the use case for native modules and turbo modules. So I'll just quickly run it. Yeah, so let's say you are building like some sort of notes application or any sort of application in React Native. Now with React Native, the benefit is that we can create like amazing user interfaces and everything would look great. But let's say, what if you want to extend your application to have much more native features to it? Now, since React Native doesn't really support a lot of native features, that is where like turbo native modules would come into play. Now, let's say now in this case, I'm running on an iOS device. So for example, in iOS, we basically have this global search where we can search anything. So like, let's say if I search for map, it would search inside like settings, app store, website, would basically search everything where it can find any sort of search result for map. And let's say now we want to make the content in our notes application actually be searchable. Now this is directly again not supported by React Native, but with the native modules we can very easily achieve it. So for example, let's say I have this note here that is named as Mastering the Art of Productivity. I've actually already set up the native modules, so I will just showcase the demo for it. So right here, if I'll type something like mastering, I'll get the search result that is basically the note that is Mastering the Art of Productivity, and I can long press on it to actually get the content as well. And even here, if I'll go back to the application and update the actual node content, so let's say I'll change it to something like mastering React Native and save it. Now if I'll go back to my search and I'll again like search for mastering, I'm getting the updated search result as well, that is mastering React Native. Now to do this, it's actually pretty simple. What I did was that I made a native module with two specific functions. One is called as index item and the second is basically a clear index function. Now this index item method has the node ID, the node title and the subtitle which I want to index. And on the Xcode side, this is the implementation for the native module. So here the same similar function is defined, that is the index item function in Swift. I'm getting the ID, the title and the subtitle. I've imported the core Spotlight framework that actually handles the indexing of these items. I'm creating a very simple, like this is all again from the documentation. So I'm simply creating a searchable item object where I'm setting like the title and the subtitle of the actual search item. And once this particular object is created, I'm searching it in the default index. So this is the actual specific line that makes the item to be searchable. And for simply state management and like updating the nodes, I just have this clear index function that is going to delete all the items so I can reindex them and have the updated search results available. And yeah, like this is like you can connect with me on LinkedIn and GitHub. All the code that I have for the demo is actually present on my GitHub. I'll share it later. But yeah, like that's all.